Hello, today I'm going to talk to you about electrolytes, and you've probably heard the word electrolyte before. Most people think of electrolytes as being sports drinks like Gatorade, and that's actually the same stuff as the electrolytes I'm talking about now. So electrolyte is just a fancy word basically for a solution that has ions in it. So we learned about ions back in the bonding unit, but anything with a charge is an electrolyte because it can conduct electricity. And we need those electrolytes in our bodies, and we lose them when we sweat, which is why sports drinks contain extra electrolytes to help you replenish them. All right, so let's take a look at what actually that means. So the most common kind of electrolyte is an ionic compound, or just a salt is a generic name for an ionic compound, that dissociates into its separate ions when we put it in water. So dissociation is just when the ions separate from each other when they go from the solid form into the dissolved form or the aqueous form. So if we were to write an equation for that, it would look like this. So this is a representation of NaCl. So we have Na plus ions and Cl minus ions. And when we put sodium chloride or table salt in water, it dissolves. And when it dissolves, it dissociates. So the two ions separate. Right, and then we know that the water molecules have partial charges because they are polar. So the sides with the hydrogens have partial positives, so they'll orient around that negative charge because of the attraction. And then the partial negatives on the oxygens will orient around the cations that are in solution. Okay, so any soluble ionic compound, so any ionic compound that will dissolve in water will also dissociate in water. You can't have an ionic compound where the charges stay together when you dissolve it. All right, so we have three different kinds of electrolytes: strong electrolytes, weak electrolytes, and non-electrolytes, which isn't really an electrolyte. Okay, so strong electrolytes dissociate completely when you put them into water. All right, weak electrolytes dissociate partially, so some of the ions will separate, but some of it will stay together, and I'll show you an example of that. All right, and then non-electrolytes don't dissociate at all. Okay, so these would be things that are not ionic compounds, and they aren't going to separate into ions when you put them in water. So if we look at a solution of strong electrolytes, it's all ions. There are no neutral particles there from what we dissolved. A weak electrolyte has some ions and some molecules. So some of the molecules stay together, but some of them will separate into ions. And then a non-electrolyte is going to be all molecules, all right? So they will stay together when they dissolve, and all of the particles will be neutral. So because of the charges, we can conduct electricity. So strong electrolytes conduct, weak electrolytes conduct, but not quite as well. And then non-electrolytes do not conduct electricity. All right, so some examples, like I said, any ionic solid that dissolves, and we'll get to dissolving later in this unit, but any ionic solid that dissolves is going to be a strong electrolyte. And then there are also some things called strong acids and strong bases that also dissociate completely. HCl is one example of that. Weak electrolytes are usually weak acids and weak bases. So water is an example of that. This is nitrous acid. That's also an example of a weak acid. Vinegar is a weak acid. It has acetic acid in it. Those are all examples of molecules that will dissociate a little bit in solution, but not completely. And then non-electrolytes are going to be are going to be things that are just molecules that don't dissociate at all. So ammonia, this is, sugar, caffeine, any of those molecules that we talked about in the last unit would be examples of non-electrolytes. All right, so for the particle diagram, I didn't put it on the previous slide just because of space, but strong electrolytes, if you were to be able to zoom in and look at the particles, so here I've not shown the water molecules, just the thing that we've dissolved. So this would be all positive and negative ions, all right? And it's important to note that there's going to have to be an equal number of positives and negatives, all right? We have to have a solution that's neutral overall, just like when we made ionic compounds before, we had to have them be neutral. Right? For weak ones, you'll have some that stay together, like is shown here, and then some will separate. But again, the number of positive and negatives has to be the same because they all came in pairs, right? And then for a non-electrolyte, it would just look like molecules floating around. There are no charges. There could be partial charges for it to dissolve in the water, but there will be no full ion charges. All right, and then just to review what we talked about with conductivity, or what I said we'd come back to, non-electrolytes, if you were to hook up a light bulb with 2 electrodes, non-electrolytes can't transfer electricity from the one side to the other, and so the light bulb would not light up. All right, strong electrolytes have lots of ions there, and so they're capable of helping move that charge through the solution, and you'd get a pretty bright light bulb. And then weak electrolytes, you have some ions, so you would get the light bulb would light up, but it doesn't light up as bright as the strong electrolytes. All right, and this brightness would also be related to how much of the electrolyte you dissolved in the solution in order to get the ions that are there.